31. A small sphere is launched horizontally with a speed v0 toward the target a horizontal distance d away. The sphere lands on the target that is at height h below the height from which the sphere was launched. If the sphere were launched again, but with a speed 2v0, how high above the target would the sphere have to be launched horizontally to hit the same target, still a horizontal distance d away? One productive way to look at this is by making sketches. In the first case, you cover a distance d by having an initial velocity v0 horizontally and going down a distance h, so the vertical displacement is minus h. In the second part, you have a higher velocity, and so you cover the same distance d starting from a position that is probably less than the original one, because your new velocity is twice v0. Now, if we consider that you need to reach a displacement d in each of the cases, you might look at this way. v0 has to be equal to the distance divided by the time of light. On the other hand, in the second part, 2v0 has to be equal to the same distance divided by a new time of light, which basically means that you need to cover the same horizontal distance in half the time. 2v0 t prime, and it's also equal to v0 t, then the v0 can cancel and t is equal to 2t prime. So the second time is equal to 1/2 the first time. As for the vertical displacement, in the first case you have that the displacement is equal to the vertical initial velocity, which is 0, times time plus 1/2 acceleration times squared. So minus h is equal to minus 1/2 g t squared. In the second part, minus h prime has to be equal to minus 1/2 g t prime squared. But t prime is half t, so what we have is that h prime is equal to 1/2 g times 1/2 of the time squared. You separate this judiciously, you should have 1/4 of 1/2 g t squared. But the parenthesis is equal to h, so what we are saying is that h prime is equal to 1/4 of h, and that means that we have to start from 1/4 of the height, which is option E.